Hello guys, you are welcome to our physics class today. In today's video, we are looking at this question on the board. It's coming from conversion of galvanometer. Actually, a student brought this question to me, and after solving this question, I discovered something, okay? And that is what I want to review to you. With what she solved, she was actually right, but the option confused her. And that is what I want to show you. So, like I said before, this is conversion of galvanometer. You can convert a galvanometer to an ammeter or voltmeter. Okay, for you to convert a galvanometer to an ammeter means you want the galvanometer to read like an ammeter. And to convert a galvanometer to a voltmeter, you want the galvanometer to read like a voltmeter. Okay, now to do this, you have to connect a suitable resistor, either a shunt or a multiplier, depending on what you want to convert to. Now, to convert a galvanometer to an ammeter, you have to connect a shunt to the galvanometer, and you are connecting in parallel. So you are connecting a shunt in parallel to the galvanometer. Okay? Note, JAMB can ask you to convert a galvanometer to an ammeter. Which of the following is true? Are you connecting the shunt in parallel or you are connecting in series? The correct option is that you are connecting the shunt in parallel connection of shunt. Okay, that is to convert a galvanometer to an ammeter, you are connecting a shunt in parallel to the galvanometer. Shunt is a small resistor. Okay, so you can use this to remember that. Okay, to recall that, you can say gaps. That is, to convert a galvanometer to an ammeter, you are connecting parallel shunt. Okay, with this you can remember that. And the opposite becomes the case when you are converting. The opposite becomes the case when you are converting a galvanometer to a voltmeter. That is, you are going to connect a multiplier, that is a big resistor, in series with the galvanometer. Okay, so that is it. But to convert a galvanometer to an ammeter is parallel shunt, gaps. Okay, so that is for that. Now, this first question, a galvanometer has a resistance of 5 ohms. By using a shunt wire of resistance 0.05 ohm, the galvanometer could be converted to an ammeter. So what we are doing here is converting a galvanometer to an ammeter. Okay. Could be converted to an ammeter capable of reading 2 ampere. What is the current through the galvanometer? So the question here is to calculate the current of the galvanometer. Now, some of you might try to memorize the formula to solving this kind of question, but you don't have to. When it comes to conversion of galvanometer to an ammeter or voltmeter, you don't need to memorize the formula. What you have to do is to understand the basic concept behind the process. Then you can do your thing normally. Okay, let's go. Now, like I said before, to convert a galvanometer to an ammeter, you are connecting your shunt in parallel. So, and this is the diagram here. This is the diagram illustrating the conversion of galvanometer to an ammeter. That is, the galvanometer is connected in parallel to the shunt. How is it parallel? You can see the current splitted at this junction, so that some will be entering the galvanometer and the rest entering the shunt. So that means these two elements are in parallel. But when it's a series connection, you will see that the current will be entering both circuit elements. Okay, but this is parallel connection because the total current, when it gets to this junction, then it will split and some goes there and the rest enters the shunt. Now, in parallel connection, the two circuit elements will be having the same potential difference. So the potential difference of this will be equal to this. That is the most important thing you should note here. That is, in parallel connection, the circuit elements are having the same potential difference. Therefore, we have that the voltage of the galvanometer must be equal to the voltage of the shunt. Yeah, potential difference are the same thing in parallel connection. Therefore, from Ohm's law, we know that voltage is IR. Okay, this implies that the current of the galvanometer times the resistance of galvanometer, the resistance of the galvanometer is equal to the current of the shunt times the resistance of the shunt. Okay, this is the same thing as this. Now, this is the formula you need to use to solve this question. But before we continue with, we proceed with the question, you need to note that the current of the galvanometer, this current of the galvanometer, is the same thing as total current minus the current of the shunt. Take notes. And similarly, the current of the shunt is equals to the total current minus current of the galvanometer. Please take note of that, because sometimes you might not be given current of the galvanometer directly, and sometimes you might not be given this current directly in the question. So you have to take note of this, that if the current of the galvanometer is not stated directly in the question, current of the galvanometer is also given as the total current minus current of the shunt. If the current of the shunt is not stated directly in the question, then current of the shunt is the same thing as total current minus current of the galvanometer. Okay, take note of that. So we can proceed now. So from this very question, let's bring out the parameter given in the question. A galvanometer has a resistance of 5 ohm. So resistance of galvanometer is equals to 5 ohm. By using a shunt wire of resistance, that is the resistance of the shunt, resistance of shunt is given to be 0.05 ohm. Resistance of shunt is equal to 0.05 ohm. Okay. Now, the galvanometer could be converted to an ammeter capable of reading this. This current given here is the total current, or the current of the converted galvanometer. Take note of this parameter. If you are unable to state the parameters correctly, you are failing the question. Okay, so this total current here is the current that the converted galvanometer will read. The current of the ammeter obtained after the conversion, that is this current here, the total current. Okay, so this implies that total current is equals to 2 ampere. What is the current through the galvanometer? So the question, the required here is current. Current of the galvanometer is the question, that is the required. So we can go ahead and plug in our values here and make subject of formula, get our answer. Okay, let's go. So here you can see that the current of the galvanometer is the required, and the current of the shunt is not stated directly in the question. We can see there is no current of shunt here, so we have to use this. Current of shunt is the same thing as total current minus current of galvanometer. So we're going to replace this here with the whole of this. because they are the same thing. Current of shunt is the same thing as total current minus the current of the galvanometer. Okay, so we go. We have that. I will change this formula to something like this. Current of galvanometer times the resistance of galvanometer is equal to, instead of putting current of shunt, I will replace it with total current minus current of the galvanometer, because they are the same thing. So we have total current minus current of galvanometer in brackets, that is replacing this current of shunt, then times resistance of shunt. So this equation is the same thing as this. Just replace this current of the shunt with total current minus that of galvanometer, which is the same thing. Now you can go ahead and make your substitution. So let's plug in our value. So we have current of the galvanometer here is given, that is the question, that is the required. So we have current of galvanometer, then multiply by the resistance of galvanometer, which is given to be 5 ohms, times resistance of galvanometer is equals to, total current is given as 2 minus current of galvanometer, which is the required. Required. Then multiply by current resistance of the shunt. Resistance of shunt is given to be 0.05 ohms. So you can now open the bracket by multiplying through with 0.5. So we're having 5 times current of galvanometer will give us 5 currents of galvanometer is equals to this multiplied by this 2 times this will give you 0.1, then minus 0.05 times current of galvanometer will give you 0.05 current of galvanometer. Okay, now collect your like terms. We are having 5 current of galvanometer. Then when this crosses the sign of equality, here it will become plus. Then we are having plus 0.05 current of galvanometer is equals to 0.1. Now add up this. That is 5 plus 0.05. 5 plus 0.05 will give you 5.05 current of galvanometer is equals to 0.1. Okay, now divide both sides by the coefficient, which is 5.05 all over 5.05. Then this go against this. Then bring down your current of galvanometer, which is equals to 0.1 divided by 0.1 divided by 5.05. You'll be getting 0.0198 something. Now this is where you have to pay attention. Okay, now the student that gave me this question actually solved till this very point, but the issue is that the option given is expressed in a different form. Okay, now this is 2 milliampere, 10 milliampere, 20 milliampere, and 25 milliampere. Okay, the correct option here with this now is 20 milliampere. Now this is it. You can express this in different form. With your scientific notation, 0.0198 is the same thing as 1.98 times 10 power minus 2. That is, you have to move this decimal point till you cross the first non-zero. And that is, I move 2 times. This is 1, 2. You can actually move any number of times you want. So if you move once, you will have times 10 power minus 1. If you move twice, you'll be having power minus 2. So If I move 3 times, that is 1, 2, 3, and drop the point here, I'll be having 19.8 times 10 power minus 3. If I move 4 times, I will be having power minus 4, and that will give me 198 times 10 power minus 4. That is moving 4 times. 1, 2, 3, 4. So now 10 power minus 2. 10 power minus 2 means centi. 10 power minus 3 means milli. So this is the correct option with what we have there, because 10 power minus 3 means milli. So we have 19.8, and 19.8 is approximately 20. That is, collect 1 here, add here, becomes 20. So you're having 20 milli. This is your milli here. 10 power minus 3 is milli. Milliampere. Ampere is the unit of current. Okay, so you have 20 milliampere. Not 2 milliampere. Neither is it this nor this. So this is the correct answer.